Right triangles, preview video 5.4, part 2, applications. Sit tall. Ready? Inhale. Breath. Taking a look here, date, time, and location that you're watching this, parental affirmation that yes, you actually followed along. I'm going to do one problem with you, and then you're doing one problem on your own, and that's pretty much all there is to it today. Ready? Now, when you're working through more complex word problems, the first thing you want to do is finger track and read. Please follow these steps. So you're going to put your finger right there. See if you can't read aloud exactly with me. Read. An airline is, okay, read with your lips moving, children. An airplane is flying at 5,000 meters altitude. The plane is 72,000 meters diagonally from the end of the landing strip. At that moment, what is the angle of descent or depression of the airplane coming in for a landing? Step 2, we highlight or underline our key concepts. The plane is at a 5,000 degree altitude. It is 72,000 diagonally from the end of the landing strip. We are looking for the angle of depression. So we have here, we start drawing, label our drawing, listing the given information if needed, and then have, need, do. So we have an airplane of some sort. You could probably draw a much better airplane than I can. And we have a ground and a landing strip. Airplane is 5,000 meters altitude. Altitude is always at a right angle to the ground. So that's 5,000. And then we have a 72,000 diagonal distance here. 72,000 meters, and this is meters. You're looking for the angle of depression. Now, let me tell you what it's not. Warning, that yellow angle right there is not the angle of depression, because an angle of depression starts at a horizontal and goes down. That's vertical going out. So your angle of descent or depression starts at a horizontal and angles downward. So that is the theta we're looking for. Whenever you see angle of depression, I'll give you a hint. You're always going to end up with a rectangle, rectangle with two congruent triangles and armpits of the Z. So theoretically here, once you draw this, you can solve for either theta. You're going to get the correct answer. I'm going to stick with this theta up here because that is the true angle of descent, whereas this would be the angle of elevation to the airplane. So, have, need, do. From that theta, this would be the opposite side. This would be adjacent. This is our hypo. We have the opposite and the hypo, and we need the angle theta. So we have an OH combo that's going with sine, but it's inverse sine because we're finding the angle. Watch carefully. Inverse sine, opposite over hypo, is going to get you that angle theta. So it's inverse sine, 5,000 divided by 72,000. That gets you the angle theta. Taking a look here. Making sure you are in degree mode, down, down, over, enter, clear. So it is second function sine. Your opposite is 5,000 divided by 72,000, which is your hypo. Enter. Round to the nearest whole degree, which is 4 degrees. Over here, you go the other way. 5,000 divided by 72,000. Second function, sine. Again, 4 degrees. So your theta here, your angle of descent, is 4 degrees. Approximately 4 degrees. All right, students, this problem, I'd like you to follow the exact same steps I did. You're going to start by finger track reading out loud. Then you're going to underline your key words and phrases. The drawing is partially done for you, so you're going to label your drawing, and at some point you're doing a have, need, do. Please do not cheat here. Do not cheat here. Do the work, then check. It will be a much more enriching learning experience if you're correcting your work rather than just copying the video. So taking a look here, I'm going to set a timer. I'm going to give you 3 minutes to attempt to do this on your own. Then you're going to correct your work. You have 3 minutes. Okay, grab a red pen. I'm going to be looking for corrections on this page. Wheelchair ramp covers 3 6-inch high steps. 3 6-inch high steps. So 1, 2, 3, and they're 6 inches each, which means this complete distance straight down is going to be 18 inches at a right angle. Close it up. It said the ramp is 4 feet in length. So the actual ramp here is 4 feet in length. Notice the discrepancy in the units, 4 feet, 18 inches. Find the angle of elevation, which is going to be this theta right here, of the ramp round to the nearest whole degree. So we're asking, what is that theta? From that theta, let's label our opposite adjacent hypo. This would be our opposite. This would be the adjacent. This would be the hypo. What do we have? We have the opposite and the hypo. That's an OH combo. You're using sine. However, because we're finding an angle, we're using inverse sine. So it looks like this. Inverse sine, our opposite is 18 inches over 4 feet equals theta. But there's a problem. We have a discrepancy in units. So I'm going to take that 4 feet, translate it to inches, which is 4 times 12 is 48 inches. So sine, inverse sine, 18 over 48. Now that's inches, that's inches. We no longer have a discrepancy in units. Taking a look here. So it's going to be inverse sine, 18 divided by 48, enter. And right here, 18 divided by 48, enter, second function, sine. Either way, you should be getting approximately 22 degrees. If you got this correct, I expect big star smiley, woohoo, yay, something like that. Many of you probably forgot one of 3 steps. And if you did, I expect a note in the margin. What are you going to remember next time? Some of you forgot that your entire vertical distance was 18 inches, not 6. That's one most common mistake. The second most common mistake is you used the wrong ratio. Did you use the wrong ratio? What did you overlook? Third most common mistake is you forgot to align your units before you actually used your calculator. So be specific. What mistake did you make? Totally okay, you made it, but I expect a note in the margin of your notes.